Probability simulations. Our essential question today is, what is the difference between experimental and theoretical probability? Theoretical probability, that's the kind of probability that you're used to working with. That probability is all about what you expect to happen. So it's based on the number of favorable outcomes divided by the number of possible outcomes. The experimental probability is a little bit different because it's got the word experiment in it, so you actually have to carry out an experiment. So the experimental probability is what actually happens. The results of an experiment. So it's the number of favorable outcomes that you get in your experiment divided by the number of possible outcomes. In a simulation is an experiment. So it's where you do a series of trials and you record your results. Okay, so 3 new vocab words. Theoretical probability, what you expect to happen. Experimental probability, what actually happens after you've carried out an experiment. And a simulation is another name for an experiment or a series of trials where you record your results and analyze them. Okay, make a probability distribution for rolling a fair die. So we know that a fair die, so one fair die has the numbers 1 through 6 on it. We know the theoretical probability of rolling each number is just 1/6, because each of those outcomes are equally likely. 1/6, if I turn that into a decimal, is 0.16 repeating. So that's what we would expect our probability to be. Each number equally likely with a probability of 0.16 repeating. Now the results of a simulation. In red it says, now let's roll a die 20 times and record our results. How do the two different probabilities compare? So if we roll this die 20 times, 6, 2. So I'm just going to make a tally chart first. 5 more. Okay. So, my probabilities from my experiment, out of 20 times rolling, 1 out of 20 is 0.05. 7 out of 20 is 0.35. 0.05. 3 out of 20, 0.15. Wrong number here. If I add up all of my probabilities, it should add up to 1. So 35, 40, 45. Yep. Total probability of 1. So how do my results compare? How do my results compare? Let's take a look at how many of these are close. 1. Only one of them is really close to what we expected. A couple of them are a lot higher, a couple of them are a lot lower. You could say that this one's kind of close, I guess. So both of those, but that's it. So my experimental and theoretical probabilities are very different, very different. And that can happen when you carry out an experiment. Typically, the more trials you do, the closer the two probabilities will be to each other. So if everyone in the class did this, our results as a whole class are typically pretty good. But just doing 20 trials didn't give me such accurate results. Okay, the next problem is talking about a deck of cards. What is Mike's experimental probability of drawing a spade? Well, looking at the table with his results, I see that spades, he drew a spade 3 times. Now, the other number that I need for my probability I can find by adding together how many trials he did. So, 2 plus 4 plus 2 plus 3 is 11. So, his experimental probability of getting a spade is 3/11ths, or 0.27 repeating. How does this compare to the theoretical probability of drawing a spade? Well, there are 4 suits in a deck of cards, and there's an equal number of cards for each suit. So I would say the probability of getting a spade, theoretically, you could say there are 13 cards out of 52 that are spades, and that reduces to 1/4, or 0.25. So his results are very close to what we would expect. What could you use to conduct the following simulations? When you're conducting a simulation, you often use something like what you see up at the top over here, a spinner, a fair die, a coin, a bag of marbles. You use something to simulate the situation. So getting a multiple choice question right on a test, if there are 4 choices, I would definitely go with the spinner with 4 equal pieces, or 4 equal sections. The next one, getting a true-false question right on a test, there are 2 choices, so I would go with the coin on this one. And you could say heads equals true, tails equals false. And then the third one, getting a defective toy, when 1 in 10 toys has a defect, That would be good with the bag of marbles. And you would just have to have one that was different. So like the bag that I drew up above, the defective would be red. And all of the other colors would mean that they were not defective. Because there's only one red marble and the other three colors combined wouldn't matter. They just wouldn't be defective toys. Okay, now we are going to do a simulation. So I want you to number your paper from 1 to 5. And I want you to guess. I want you to guess true or false. So we're going to simulate what happens if you guess on a quiz where you've got 5 questions and there's only 2 choices for each. So I'm just going to go true, false, true, false, true. Now, what could we use to simulate this event if there are 2 choices? A coin, which is what we just said on the last one. So I'm going to simulate this, and I'm going to use heads for true and tails for false. So I have heads for the first one, so that means true. So I got that one right. Tails. Got that one right. Tails. Wrong. Heads. Wrong. Heads. Right. So, how did you do? I got 3 out of 5. So that would be 60%. That's a D minus. I'd say I didn't do very well. Now, my experimental probability, so my experimental probability was 3 out of 5, or 0.6, for getting all 5 questions right. What is the theoretical probability? The theoretical probability of getting all 5 questions right, well, your chances of getting the first question right are 1 out of 2. Same with the second, same with the third, same with the fourth, same with the fifth. So, if I multiply these fractions, 1 times 1 times 1 times 1 times 1 is 1, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 1 divided by 32 is 0.03125. So about 3%, or 3 out of 100 people would guess and get all 5 of these right. So if I take my exact decimal and multiply it by 36 students in a class, 1.125, so about 1 student would get a perfect score. That's what we should expect. So expect 1 perfect score in a class of 36 students. You should be able to write your summary now. And we only have one homework problem because it involves doing a simulation of your own. I believe it involves dice. If you don't have one fair die at home, you can probably find one online to use for your simulation, just like the ones that I used here.